So let's move on to the next problem. Let me explain the problem to you. We have a standard deck of 52 cards. We can turn over two cards at a time, right? If both are black, they go to the dealer. They go to the dealer. If there's a black and red, uh, they are discarded, right? They are discarded. And if both are red, they go to your pile. Right? Okay. So this process continues until all the cards are used, obviously. And then you win, $100 if you have more cards, if your pile has more cards than the dealer, right? Otherwise, you don't win anything. Okay, so you can look at this initial setup that has 26 black and 26 red cards, right? And when you pick up a card, or rather, when you pick up two cards, you can have three outcomes: black, 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 red, and red, red. These are the three outcomes. So, fine. You've seen all the, I think, possible scenarios. Okay. So you can see that we start with an even number of cards of each color, right? And each discard reduces one black and one red card, and the discarded cards are always in pairs, right? So let's say if X number of BR pairs have been discarded, and if you this is the, like, let's say let X be the number of pairs discarded, the number of black cards left would always be 26 minus X, and the number of red cards left will also be 26 minus X, right? And the remaining 26 minus X black cards and 26 minus X red cards, are assuming that they'll come out in a black black and or a red red pair, right? Because all the BR pairs have been discarded, black red pairs have been discarded. So do you see a fundamental problem with this question, right? Because you're let's say discarding let's say because you're discarding equal number of black and red cards, your number of cards in the end, which is the total, which defines the total size of your pile, will always be equal to that of the dealer, right? So there is no scenario where you could have, where your your pile would be larger than the dealer's pile, and because the rules of the game say that in case of a tie, your dealer wins and you get nothing. So this game is inherently flawed. It is inherently rigged. So there is no possibility in which you can ever win. So what you should be paying is to play this game is zero, and you should rather be not willing to play this game. So that's the answer. In a normal situation, let's say if the game was fair, then we'd probably be looking at the probabilities of you winning and the payoff in that situation, and we'd be multiplying each of those payoffs with the probabilities, and then we'd probably get an expected value which would expect to earn, and the amount you're playing would probably be near that value. But in this situation, the game is rigged, and you paying money to play the game doesn't make any sense. So the answer is $0, or you shouldn't be really playing this game. That's it. If you have further doubts, do let me know in the comments below. Thank you.